Hello everyone, my name is Ahora Shafar and I'm here to talk about my medical alert model. Now this model is used to detect breast cancer in women, and I'll start by talking about features of a notebook of and this in this case my notebook is all about breast cancer detection, and I'll begin with a heat map. The heat map is a presentation of data in the form of a map or diagram in which data values are represented in colors. And since colors can easily be distinguishable, this is so common when dealing with large volumes of data. So it gives a more generalized view of majorly numeric data. And then we go to a correlation matrix. It displays data. A correlation matrix displays that correlation coefficients of data, and it is used to summarize data as an input into a more advanced analysis. It shows the relationship between the dependency between a variable and another. That is the coefficient, the correlation coefficient. Then we go to box plots. Box plots I use it to show distribution of numeric values, especially when there is need for comparison. And this is done majorly to show, it normally shows the minimum, first quartile, third quartile, median, maximum. And for a box plot, quartiles, that is the third quartile and the first quartile, the differences are calculated, and then a stacked column chart is created, which converts it into a box plot style. So these are screenshots of what I did in my notebook, as it could not all fit in a slide. So I took a screenshot of each and everything. So this is a heat map. This is how a heat map looks like, and one can even choose other colors that they would want, and some little code of how it is gotten. And then this is the correlation matrix. This is the data I had. And then now these are box plots. And then now we go to feature independence plot and outliers. Observations are independent when the occurrence of one observation does not affect or provide any information about any other observation. So it is majorly done with plots. It can be done with plots, and then you calculate each feature by feature alone. And then you show the independence that a feature can exist independently from another. And then outliers, these are points that significantly they are significantly different from the rest of the data set or other observation. So these outliers normally arise due to inconsistency of the data entry. They are always far away from the data that's there. They are not the same as the whole data set. They're always outside, and they differ from the rest of the data set. So these outliers can easily be detected by box plots, histograms, and scatter diagrams or plots. So now we go to some partners in how the data can easily be represented, and majorly they are represented in graphs, and I chose a histogram for my data to be represented in histogram. So this is a histogram. These are histograms for each feature, the feature by feature. So this is texture, perimeter of the breast. So these are the histograms that represent all those features. So this suitable, a pattern is suitable if it's easily understood by both human beings and the model that you are using. So they should easily be valid with some level of certainty that they can easily be understood. And then you see this in the rise, and then introduction. So then after that, I went into testing, training, and validation of my AI model. And this is the code, which is in the notebook. And yeah, this is how they look like. I first split my code into 3 parts, where one is going to be used for trading, and then another one is going to be used for testing. And then, yeah, I divided it into two, where one is going to be used for trading, another one for testing. And this is the code for it, the one that I used. Yep. And then the trends in time and space, I use a graph to show it. So they can, because they can easily be represented in graphs. So this is how I did mine. And this is how it looks. It contains the diagnosis as my x-axis, and then the ID as my y-axis. Yeah, so that's all for my PowerPoint presentation, and this is how